You're bleeding money on your LLM API calls. Here is the exact architecture fix that saved 27%, and it's not about finding a cheaper model. It's about fixing the stack. When we scaled our agent from prototype to production, the cost jumped exponentially. The latency was spiking, and the usage logs were terrifying: high token count, poor signal-to-noise ratio. The initial symptoms, slow response times and unpredictable bills, were a symptom of architectural overuse. We were treating the LLM as both the database and the thinking engine, forcing it to do everything. Our primary bottleneck wasn't the model itself, it was the prompting inefficiency. We were stuffing complex instructions into every single prompt, forcing the LLM to read irrelevant preamble. The fix started by segmenting the task. We stopped using one monolithic prompt and broke it into a three-stage pipeline: extract, decide, generate. Stage 1 used a low-cost, high-speed model, think GPT 3.5 Turbo, solely for initial classification and intent extraction. This was cheap, fast, and highly accurate at its narrow job. Only if the intent was complex or ambiguous would we escalate it to our expensive, powerful flagship model for deep reasoning and synthesis. This is dynamic routing. This concept is called cascading agents. You are not paying GPT-4 to read a novel when it only needs to check the table of contents. The second massive win came from knowledge retrieval. Instead of stuffing all context into the prompt, we implemented RAG, retrieval augmented generation. We didn't feed the LLM our entire knowledge base, we fed it only the 3 to 4 most relevant chunks of information, dramatically lowering token count and improving focus. This shifted the LLM's role from the knowledge base to synthesizer. It no longer needed to search, it just needed to reason on targeted facts. But the biggest hidden drain was repeated computation. Every time a user asked a question, we were running a full inference cycle. The final layer of optimization was implementing a smart caching mechanism. If the exact same query arrived within a set timeframe, we served the cached response instantly. This simple cache layer absorbed a significant percentage of redundant traffic, saving both time and compute power during peak usage. Finally, we wrapped the entire system in guardrails. We added a lightweight validation layer before and after the main call to catch hallucinations or budget overruns. This wasn't just about cost, it was reliability. The guardrails ensured predictable behavior and prevented runaway token usage on edge cases. The combination of these 3 shifts, cascading models, targeted retrieval, and smart caching, is the playbook. The result? We slashed operational costs by 27%, moving from a fragile prototype to a robust, profitable enterprise application. And crucially, the average end-to-end latency doubled. The user experience went from a wait for generation to near instantaneous interaction. If you are running a production AI application, don't treat the LLM as a black box. Treat it as the brain of a distributed system. Optimize the stack around the LLM. Segment the tasks, control the flow, and your costs will thank you.